Let's do another example. Example 2. A company has a policy of requiring a rate of return on an investment of at least 12% effective. Well, we know that 12% effective means 12% compounded annually. So let's make a note of that. Two investment options are currently available, and the company has to select one of them. All right. Option number 1 offers a return or a payback of $90,000 after 4 years, a $60,000 payment after 8 years, and $50,000 after 10 years. Option number 2 will give the company back, or will return the company $1,600 at the end of every month for the next 10 years. Which investment option should be selected? And we're going to round our answers to the nearest dollar. Well, again, I cannot compare 3 single payments made at different time periods with a value of $1,600 per month made over 10 years. They're different time periods. I have to bring them back to a common denominator or a common base. So I'm going to use a common focal date, and that focal date is going to be today, or 0. And I'm going to say, let's take a look at option number 1. So option number 1, we will receive payments of $90,000 after 4 years. So that's going to be after 4 years, we're going to be receiving a payment of $90,000. And in addition to that, our payback is also going to be $60,000 again after 8 years. So on my timeline, I will show an 8-year time span with a $60,000 payment. And the last payment will be $50,000 after 10 years. So after 10 years, we'll have a $50,000 payment. So the total that's paid out is going to be 90 plus 60, which is 150 plus another 50. That's $200,000 over time. It will not have a value of $200,000 today. We need to find the present value of option number 1. And how are we going to find the present value or the cash value of option number 1? Well, the present value of option number 1 is going to be the present value of each of those successive payments. So we've got $90,000 and we have to find its present value. How do we find the present value? Well, we need to discount it. We're going to be discounting it, or bringing it back over a time period of 4 years at an interest rate of 12% effective. So I/Y is equal to 12%, and the compounding periods per year is equal to 1. We have no pay. This is not an annuity, so I'm not even going to bother with payments per year because it's not an annuity. It's a single lump sum payment. So I'm going to be using the discount formula. So we've got $90,000 discounted at 1 plus 12% per year for how many yearly periods? Well, n is equal to 4 in this case. I'm going to be discounting over 4 years, but it's going to be a negative 4 exponent because I need to discount it. And I'm going to add to that the $60,000 discounted over a longer period of time. It's going to be discounted over 8 years. So $60,000 discounted at 1 plus 12% per year for n is equal to 8 years. So we're going to have negative 8 as our exponent. Plus that last payment is going to be $50,000 discounted at 1 plus 12% per year for negative 10 years. So each of those needs to be worked out on your calculator. And so the first value works out to be a discounted value of $57,196.62. That means that it would take $57,000 investment today at 12% compounded annually, or 12% effective. It would amount to $90,000 after 4 years' time. What I'm going to do is I'm also going to recommend that you store this in memory 1. So I'm going to make a note here that we will store this in memory 1 and carry on so that we don't have to, we won't run the risk of making any calculation errors. The second amount of money, $60,000 due in 8 years, has a present value of $24,232.99. Again, I'd like you to store that in memory 2. So store that in memory 2 so that you don't run into any round off or calculation errors. And the third amount of money amounts to a present value of $16,098.66. Again, you're going to store that in memory 3. So store it in 3. So in other words, it'll take $24,000 to accumulate to $60,000 at the end of 8 years. It will take $16,000 today to accumulate to $50,000 in 10 years' time. So what is the present value or the cash value of all 3 payments today? How much money would it take today to generate those 3 payments? Well, that would be recall 1 plus recall 2 plus recall 3, or $97,000, 528 and 28 cents. Now let's round that off to the nearest dollar, so $97,528 in cash value. So the present value of those 3 payments, and incidentally, those 3 payments added up to $200,000 in payments, right? That has a cash value today of $97,000, 528, assuming an interest rate of 12% effective. Now we have something that we can compare to option number 2. But before we can compare it to option 2, we have to find its present value or its cash value. So let's set up a time diagram and set up the equation for finding the present value of option number 2, which is returning us $1,600 at the end of every month for 10 years. And so option number 2 gives us an income of $1,600 at the end of every month for 10 years. And this is monthly payments. So we've got 1, 2, 3. How many months do we have in 10 years? We've got a total of 120 months. And the payments are at the end of every month. So it's $1,600 at the end of the first month, $1,600 at the end of the second month, and so on. $1,600 per month for 10-year period. So we've got an ordinary annuity here, $1,600 per month at the end of every month. So there's my annuity time diagram. N is equal to 120 monthly payments. So what's the cash value or the present value of option number 2? Well, it's simply the cash value or the present value of this annuity, where the payments are $1,600 per month multiplied by the present value factor, 1 minus 1 plus the interest rate per month minus 120, because there are 120 monthly payments, divided by the interest rate per month. Now, why didn't I put the interest rate per month in there? Because I don't know what the interest rate per month is. All I have is an interest rate of 12% effective. I have an interest rate that is 12% per year. I don't have the equivalent monthly rate. And frankly, I'm going to let my calculator work this out for me. I'm going to let the calculator do all of the hard work of converting. So I'm going to enter in I/Y is equal to 12%. The compounding periods per year is equal to 1 because it's effective. It's compounded once yearly. The payments per year are equal to 12 because the payments are monthly. And I'm going to enter second quit out of here, and then go back to where I'm starting to enter in the other values. N is equal to 120 because there are 120 monthly payments. N is always the number of payments with an annuity. Remember that. And what else do we have to enter? We have to enter the fact that the payment is equal to $1,600 per month. And so now what we're going to do is we're going to compute the present value. And if you work this out using equivalent interest rates and work this out on your using equivalent interest rates formula, you will end up with the same information here. Your calculator will compute a present value, and so will the formula compute a present value of $114,328.85. So which one represents our better return on our investment? Present value of option 2 or the present value of option 1? Well, when I look at option number 1, I received a cash value or equivalent cash value of $97,528. The equivalent cash value of option number 2 is $114,328. So I would say that this represents a higher cash value. And this is the one that should be selected. In other words, the $1,600 per month should be selected over the 10-year period. And incidentally, the total payments of $1,600 per month over the 10 years is 120 times 160. And 120 times 160 is $192,000. So it's $8,000 less in total payments than option number one. And yet they still represent a higher cash value or a higher net present value using an interest rate of 12% effective. So option number two should be selected.